Hey again, guys, and welcome back. Today I want to take a look at this kit, which I got in my mailbag very recently. I don't know too much about this kit, though. I don't know anything about this kit, to be honest. Um, I don't know how to build it. There's no instructions. I'm not quite sure how it's controlled. I definitely see there's a bunch of wires here, which will probably be important to know which does what. But we have the benefit that the circuit board, at least on the surface level, seems pretty simple. And the component count is relatively low. So I think we're going to build this up, see if it works, and then maybe we can do a little bit of reverse engineering maybe in the next video and try to figure out what's going on here. So yeah, I think because I don't really know what I'm doing, and I can totally see that there's 4 wires coming off this transformer here, and there's 3 holes here. I better take a look at a little bit of information before I get going. Ooh, I don't know if it's good. Seems to be a little bit of a scraped portion of the insulation there. Oh well, let's go take a look at the eBay listing and see what this thing's all about. So here I have the actual listing I bought this thing from. And we can use a few of these images and maybe some text as some clues. So this is what I have here for sure. Oh, I don't know if I got these. I didn't. I don't really remember. But it looks like it's pretty simple. You've got switch, heatsink, screw, transformer, 3-pin device, probably a transistor, a resistor, a diode, and the board. So not much to it, that's for sure. Let's see if we can sort of get a look. Oh, there's something interesting here. I can't move my mouse over to it, but it looks like the center tap of the coil, I'm looking at sort of this part here and this part here, seems to go and be soldered together. Okay. It's a good thing to know. I like how they didn't actually sink the screw in here. If you look right at the edge there, so that transistor is not getting heat sunk. It looks like the wires over here are coming from the bottom. Okay, that's not bad. I got a zip tie in my kit. I don't know what the zip tie is for. Maybe it's for zip tying this whole thing down. But okay. So I get a little bit more information. Let's scroll down and see what we have here. Images didn't load. That's okay. That's not the one I got. I got this one, DIY kit. Booster coil production suite. Suite is like the Chinese use suite instead of kit. But then again, they go use kit as well. So I'm not sure. Simple and reliable. Professional drawings. Yeah. So 15 kilovolt transformer, outside dimensions, whatever. Input voltage, this is important. 3.7 to 4.2 volts. Okay, limit 12 volt, easy to damage, not recommended. Okay. You would need an increase in the feedback resistor. Yeah, no, I think we're just going to stick to the, let's say about 4 volts here. Input current under 2 amps. Yeah, I hope so. Output voltage about 15,000 volts. Output current, yeah, very little. But, we're going to be careful with this for sure. There are 2 primary windings. A primary winding. I'm guessing that's a secondary. Feedback winding. Oh, so primary feedback and then secondary. Interesting. Designed for maximum output, limit cannot exceed 15,000 volts. 1 centimeter arc. Yeah, I don't think we're going to make large arcs like that. High voltage does scare me a little bit, so yeah. Okay, well, this is this is interesting. So we have ultra fast recovery diode, and we have N20 transistor. Whatever that means. And we got a boat switch too. We got 1 screw, yeah, M3 by 6.
Okay. Well, with that in mind, we know that we have, we're probably going to feed this 4 volts. I guess we should put the kit together now. And the only thing we really need to pay attention to is this center one here. That center wire needs to come in. Yeah, if you look, the wire comes in from one side, in from the other, and the 2 center ones together. All right, let's see if we can put this together.
I'm not sure if it's showing up on camera, but while I was waiting for my soldering iron to heat up, I noticed there are actually 2 different colors of wire, and looks like 2 different gauges also. So you've got this kind of maroon color, you've got this kind of more coppery color, then maroon and more copper. So I think this is like a center tap, so I think both of these have to go in. This is also enameled wire, so you can actually strip it with sandpaper, but another method is to just heat it up with the soldering iron, which I think is the way I'll do it. Don't know where the zip tie goes, but I guess it's not too much to think that it goes through here and will actually zip tie down the transformer. So I guess we should get started by the simple stuff. We have a resistor. Let's see if I can figure out the color code. Brown, red. I think red is 2. Brown would be 1. So 1, 2, and then brown. So 1, 2, and 1, 0, 120 ohms resistance. And I guess that makes sense. It is a 120 ohm resistor. Pop that in there. I'm going to try to stay in shot here, but I brought you in a little bit closer. And I'm hoping I don't go out of shot too much. Okay, so our ultra fast recovery diode band is upwards. And it goes in like that. That's it for the low profile components, isn't it? Very interesting. Alright, got my solder handy. I don't think I've soldered anything since the speed build kit. So whether or not that ruined the tip of my iron because of the high voltage, the high heat I was using, is yet to be determined. Starting off great with some dry joints. Typically it doesn't matter. I think it's a little bit overblown on hobbyist level stuff. Alright. I have almost never, and I think I actually never, have had anything not work because of dry joints. It was always because of either I forgot to solder them or whatever, other reasons like that. I don't really know what order to put this in. I just do know that this backing here should go towards the heatsink. So I'm going to pop this guy in. And this becomes hard. I have lost all my sticky tack. It's probably stuck to the back of something really stupid. But regardless, it's gone. You know what? Maybe I'll put the heatsink too. Shouldn't there be a screw? Oh no. Either I've lost a screw or it didn't come with it. Damn. Let me go grab a screw. With great difficulty I found an M3 screw. At least I hope it's an M3 screw. Because I'm not going back looking for another. What? Oh, I guess this transistor has to sit a lot higher. Man, good thing I am not speed building this. Junk from work, don't even think about it. You can time this if you want, but I'm not racing. Oh no. This is terrible. I have to say, I really do like this Pick Quick screwdriver here. But what I don't like is the magnetism in the handle is not quite as much as I would like. I'm used to automotive tools where they straight up stick like N52 neodymium magnets and everything. Yeah, okay. And now again, I don't have my sticky tack, so this is not going to go particularly well. As long as I hold it there, it should be okay. There we go, that wasn't so bad. Just got to do the actual transistor now. We've got to be in and out pretty quick though. Might need to look into a silicone mat like another maker has. He's got a soldering mat. I think Learn Electronics has one too. Depends how much it costs. There we go. That's done. Is this hot? It's warm. It's not that hot. Okay, we'll do our switch here. Again, the switch will be with great difficulty because I do not have my sticky tack. I have not gone to the dollar store to refill in quite a while. I've been just really busy working at my teaching job and making videos. It's not going well. Oh, you know what? See if we can bend the crap out of these leads and have it hang on to the board for me. Scratch through the solder mask there. That's not what I wanted to do. There we go. There's really a few things I need to get for this channel, and I'm kind of procrastinating it a little bit because it is the Chinese Lunar Festival now, or at least close enough to it, that I don't think anything will get shipped out on time. So I kind of just given up from ordering stuff from China, but I think I'm going to start going back to AliExpress because eBay's policies are a lot less buyer oriented as they used to be. At the moment, for those silicone wires, they want me to ship them off back to China for a refund. But I mean, the cost of shipping to China from Canada is ridiculous. So it seems like it's a scammer's paradise again. And I don't know. I realize you do take risks when you order from China. That's kind of the deal. But yeah, I don't know. I don't know if I'm into the risk right now. I don't have really any loyalties. Like I like eBay, but if it's better value from somewhere else and I'm taking the same amount of risk elsewhere, then I'm gonna go where the value is. That's just the way it is. Really fighting this now. Hopefully Can get this in without peeling it back. There we go. Alright, so the plan with these wires, this transformer, I really do feel as though the zip tie is to hold the transformer down. I think I'm going to put it in. I've been shopping a lot on Banggood recently. Some things are simply cheaper on Banggood, but the thing is, Banggood is not the land of dollar items. That's eBay and AliExpress specialty. Banggood is more of the place where you go for stuff that are like $7, $8, $9, $10. And there are some things that are really good deals at $7, $8, $9, $10. But a lot of the electronics hobby stuff, just way better value. Buying $1 things. So here's the way I do it. Ouch. So I basically just heat it up nice and hot, feed some solder into it, and then keep the iron on the solder, and it should burn away the enamel. It does get hot enough to do that, usually. Let's see. It has not burned away the enamel. I can guarantee you that. That's interesting. Some sort of super Chinese enamel. Oh no! I burnt my zip tie. That's not good. One of the wires soldered itself. Might as well pull that zip tie out. No good anymore. Damn. Okay, well, I guess this would be a time to talk about the second way to get the enamel coating off, and that's scratching at it with a knife. Because I promise you, these did not actually burn through. I feel like it just burned through now. Yep. We are successfully alloyed there. That's good to know. I just need to get the excess off. And of course, now I took too much off. Alright, back to the original plan. As soon as I can find a knife, I can scrape away at the enamel. Knife in hand. So this is kind of what you want to do here. Is you go around where the joint's going to be. And you just give it a good scrape. It doesn't take much. In fact, sometimes these things are destroyed from the factory because they rub the wires together during assembly, and then the transformer is no good right off the bat. So let's see if we can get this to alloy now. At least one of those is soldered. I'm going to solder the outer ones first, and then I'll come back. and redo that middle one. So again, you just want to sort of take the contact point and give it a good scrape. Yeah, this thing is just not cooperating, huh? Looks like I do have these little emery boards. They're nail files. Should give that a good scratch. Okay, I'm just going to install the last component, which is these pin headers. In fact, you know what? I probably won't use pin headers, simply because I'm just going to solder wire to it. But what I will do, however... Oh, damn. That wire broke right off. Well, that's not good. See that one? Damn. Well, I do have 2 of these kits. I'll let that be a lesson to you. Let me just solder this guy on the other kit, and I'll bring you back. Well, I think I'm going to learn from my mistakes here, and I'm going to just rough up the wires here, trying to take off all the insulation. It's a little finicky. Trying this again now. It's a similar disaster. I guess I didn't scuff up the wire close enough. I think that's got it now. We'll have to check. Not convinced, but maybe. Trying to get that enamel hot. This is, I think this is the highest quality enamel I've ever dealt with. You know what? Let me bring the iron up in temperature, and maybe that'll do the trick. I'm at 430 degrees C right now, which is far higher than I usually solder. But I'm trying my best to make sure that insulation, the lacquer on the wires, is melting away or burning away. I think I've got it. One good way to find out is to do a continuity test. Can't find where I left my probes, but this should work. So basically, if these two are connected together, they are, and these two, no, oh, they are. I'll just check the pad here instead of right on the wire. So I'm going to go from pad to pad. These two should be connected. They are. Okay. It did solder. Not my finest moments here, but we'll make it work. Okay, you don't need to see me solder all the rest, so I'm just going to speed this up and we'll come back to a finished kit. I screwed it up again. I actually screwed up the switch. I overheated it. Don't know if reflowing it will help anything. Nope. Bugger that. I don't want to be near this thing when it switches on anyways, so why don't I just solder a link on it and call it a day. But even as I say that, I'm sure that link is going to be a pain in the butt to solder for no reason. Just needs to be that way today, it seems. There we go. Switch is soldered forever. Let's get some wire. And we have our negative. Come up this way and down into here. This is that same wire from that mailbag. It's the PVC jacketed stuff, which was supposed to be silicone jacketed stuff, which they want me to mail back, which I am not mailing back simply because it is very expensive to mail stuff to China. So, you know what? I'm not bothering. I will take my lumps, and I think I'll order stuff from AliExpress until they upset me, and then ad infinitum. To be fair, though, in the end, I did get a lot of good deals on eBay. I can't complain. I just feel slighted that they changed their policies to be very a lot less pro buyer. So I just feel a lot less confident in making larger purchases, I guess. And therefore, I think I'm gonna give eBay a rest a little bit. There we go. Okay. So this is now finished. But I want to make one more mod before we move on. And that is to set this arc gap. So this thing is a 1.5 or 15 kilovolt device. However, it's only 15 kilovolts at the 12 volts, and we're not going to run it at 12 volts. I don't want to adjust the resistance to fit 12 volts, and also, you know what? It doesn't really matter how much voltage is on there. I'm still not probing it with my expensive oscilloscope, So what I'll do is I will tape these relatively close together, which will not only make sure that they're not flying apart like crazy, it will also give us a maximum voltage, because as soon as the voltage reaches the amount necessary to cross the gap, then it'll cross the gap, and then that'll be it. So I'm just trying to get the two sticky bits to touch each other there. There we go. And wrap this around a couple times. And there we go. So now we have a gap of about 5 millimeters. And I think for this, I will even leave it up here, up close, so that you guys can see the high voltage arc as closely as possible. So here we go. Let me set up my power supply and I'll bring you right back. Okay, so we have our little arc gap there. I don't know if I should put something underneath it to sort of show it better. Is that better? Nah, you know what. I got my power supply going off to the side. The on-off switch is stuck in the on position because honestly, this was not a fun build. I've worked with magnet wire or transformer wire a lot, and honestly, just getting it hot usually does the trick. Not sure what happened this time, but it doesn't matter. I've got 3.9 volts coming in on a 3 amp limit, so if this thing blows up, well, it blows up. So who cares? All right, well, 3, 2, 1, go. Okay. This thing is absolutely singing. I had to turn that off. That was making a crazy high-pitched ring. That really hurt my ears. I really don't see any... I didn't see any arcs or sparks. We can try getting them a little bit closer to each other. Let's see if they'll form some arcs. Let's see. Kind of don't want to touch it. There we go. The gap is much smaller now. Let's see if it'll jump over. 3, 2, 1. Oh yeah, there's definitely an arc there. And off. Okay. So it looks like it's going to be a bit too dark to see. This is all okay here. I'm gonna move this away from each other, but point them in at the tips a bit. It's definitely going. Let me set you in a better position to see. Here's hoping you'll be able to see this, but 3, 2, 1. There you go. It's a nice purple plasma arc, but it's giving me a super high frequency ringing. Like, it is really high frequency, and it's hurting my ears basically. Don't know if the mic can capture that at all, but it is jumping. Wish I had something pretty well insulated I can go and touch it with. But that is high voltage, and I am not touching that with a probe or a scope or a screwdriver or anything like that. That looks like it would destroy whatever it touched. Hopefully you can see that. I don't know if maybe if I shade it a little bit more. Yeah, you can see it. There it is. Wow, that really hurts my ears though. Probably best not to do this at home. So yeah, I was planning on investigating this this device. I was planning on tracing out the circuitry and trying to figure out its intricacies, but I think I'm pretty sick of this kit now. Oh shit. There's no capacitor in here, so it shouldn't be storing charge. Yeah, I got pretty sick of this thing pretty quick because the kit did not go as planned. So I don't think I'll be doing any of that. Ooh, I think it's charging up the mat it's sitting on. Not sure. It's using 6 watts of power, 3.9 volts, 1.576 amps, and it is super high frequency ringing. The decibel level must be pretty high because my head hurts. It's pretty nuts. Cool little kit, but I think that's it for me. Thanks again for watching, guys.